Okay, Leontif Matrices, the next topic. And we've done something a little bit like this last year where we had a consumption matrix of, I think, coal and steel, where you need a little bit of coal and a little bit of steel in order to make 1 ton of steel. And you need also some coal and some steel to make 1 ton of coal. This is the same sort of thing, except we've just expanded it, and we've made 3 inputs and outputs here. We've got energy, raw materials, and manufactured goods. And the process will work, you can have a much more complicated system. So what these columns mean here is this is, on the top, these ER and M are per 1 unit of output. This is the number of units input required in order to produce 1 unit of output. So if we're going to have a couple more letters, P is going to be output, and Q is going to be input. Alright, so for example, if we require an output of 3, 4, 7, okay, so P we'll make these into little matrices here. So this is, again, 3 units of energy, 4 units of raw materials, and 7 units of manufactured goods. Okay, so if I want to look at how much energy is required, just look at energy for the moment, to produce this output. Okay, for each unit of energy output, okay, which is, we've got 3 units of energy being output. For each of those units, we need 0.2 units input of energy. For each, for this 4 units of raw material output, each of those 4 units requires an input of energy of 0.3 units. For each of those 7 units of manufactured goods output, each of them requires this 0.3 up here. Okay, and if you look at that, that's a matrix multiplication. Okay, that'll give us 3.9 units of energy input. Why can't I change this to a times? There we go. That should be a times. All right. Anyway, it's a matrix multiplication, and the formula is we're multiplying the C times the P. Okay, so Q is going to be C times P. So in this example, our Q is going to be, we know it's going to be 3.9 and whatever these are. Okay, well, I think we're finished with this example. So I'll just give you some questions, but here's the formula that we're going to be using for these examples. So here's some questions. The first one is, what does the 0.4 in row 2, column 1 represent up above? Okay, so what does this represent? Well, up the top, it's for 1 unit of output. So A is for 1 unit output of what? It's the output of, directly above the 0.4 is E. So 1 unit output of E. We go over to the right, this is the input, 0.4 units of R raw materials are required. Question B, what inputs are needed to produce 1 of E, 0 of R, and 0 of M? Alright, so the output, the P, is 1, 0, 0. Q equals C times P, and we'll just put it in the graphics calculator. So in the graphics calculator, this is my matrix. A is this one, and just incidentally, these numbers here, in the last ones we had to have certain columns and rows adding up to 1. That's not necessary here, but it would be strange and probably wouldn't work if any of those numbers were bigger than 1, because you would need more than 1 unit of energy to produce 1 unit of energy, so there's really no point. And matrix B is just this 1, 1, 1, so we just do matrix A times matrix B, and we get 0.2, what was it? 0.2, 0.4, 0.3, 0.2, 0.4, 0.3 units of E, R, and M are the inputs required to produce this output of just 1 unit of energy. And for C, I just have a different P. I have 2, 2, 3. So same thing on the calculator. Okay, so on the calculator I have just changed matrix B to be 2, 2, 3. So again, matrix A times matrix B, I get 1.9, 1.9, 1.7. So Q equals CP, so Q equals 1.9, 1.9, 1.7. Okay, so just incidentally here, at this point, let's have a look at what's happened here. So our output is 2, 2, 3, our input 1.9, 1.9, 1.7. So we've actually increased. We started with 1.9 units of energy, we got up to 2, so we have an increase of 0.1. Okay, that's our net gain. And same, we also have a gain in the R, the raw materials, and we have a gain in manufacture. We have a gain in all three. So this was productive. If you look at the last example, we had a loss. We input raw materials and didn't get anything out of it. As far as raw materials, we just got energy. All right, so we could look at this Q minus P basically is a surplus. That's what we've gained, and that we're going to call that, this is our demand. Okay, so this is, if we ultimately need, the economy needs to have a net gain of this demand, that means that our output has to be bigger than our input by that amount in order to have that usable by the economy. So in this example, we had 2, 2, 3 minus 1.9, 1.9, 1.7 to give a surplus of 0.1, 0.1, 1.3. So this is the surplus, or we can call it the demand. Okay, so again, looking at this equation, our equation from the previous section, we had Q equals CP. So we can substitute, and I've gone and swapped these around the wrong way, haven't I? P minus Q, P minus Q, right? Output minus input. Okay, so I'm going to sub into here, so I'm going to have P minus CP equals the demand, and I times P, I'll put an I in here, so I'm going to factor out my, okay, so I'm going to have I minus C times P equals the demand. Remember, I is, in this case, we're doing 3 by 3, so this is this identity matrix. Okay, this is what I is. And one more, we'll just do the inverse. I minus C, negative 1 times D. All right, that's the formula we need. And here is the next question. Just of note here, when you multiply out and find P, your input, if you get a negative number for P, this P stands for your output. It doesn't make sense if you got a negative. Okay, you can't have a negative output. So sometimes it may not be possible to meet the demand. If you did this calculation and ended up with a minus number for one of your 3 p-values, that would not be possible. Okay, but going through these questions, okay, find production P to meet demand D. We're using the same C from the previous question. So we need to find P just using this this equation. Okay, so again, in the graphics calculator, I've entered a matrix C, which is my identity matrix I. So just in my calculator now, this is my matrix C. This is a bit confusing, but C minus, that was the one I put in for A. I have to inverse that and times it by my matrix B. So this is in my calculator. So I'm going to do bracket matrix 3 minus matrix A, and okay, and I make that to the -1 power for the inverse, and times by my matrix B. Okay, so I get 19, I get these numbers. Okay, so this is the output that is required to meet that 5, 2, 4 demand. Okay, the next question, let's have a look. Show that it is always possible to find values for production that will exactly match a given demand D. Okay, so finding values for production that showing that there will always be values is basically showing that P cannot be negative numbers. Okay, because if you get a negative number, then you cannot find a production that will meet. Okay, so it's showing that you cannot get a negative number, and basically we're going to look at I minus C to the -1 on the calculator is C minus A to the -1, and if we scroll across, okay, if you look at all of these 9 numbers in this matrix, they're all positive. Okay, I minus C is, the point is, they're all positive. It's possible to have negative numbers there, that's fine. It's just when you multiply it times by your matrix D. If these are all positive, so matrix D, this is matrix D, demand. Well, of course, they're all positives. Your demand is all positives. These are also all positives. So if you're multiplying 2 matrices together that are both all positives, you will get an answer equals an answer with all positives. Okay? Which means as long as they're all positive, then it's possible to find a production. Okay? So can find production. Okay, therefore, let's do it more professionally. Can find a production. Okay. Okay, that'll do it. I'm going to have a swim now. I'll do one more short example video. Yep. I'll post after this. See ya.